Hello and welcome to Pomodoro Joe for Tuesday, October 10th, 2023. Today we're looking at LeetCode problem, come on, man. 2009, minimum number of operations to make array continuous. This is another hard problem. This is like the third hard problem in the past 4 days. All right, let's see what we got. So we're given an array, nums. It's an integer array. In one operation, we're allowed to replace any element in nums with any integer we want. Nums is considered continuous if both of the following conditions are fulfilled. Number one, all elements in nums are unique. Okay, no duplicates. And number two, the difference between the maximum element and the minimum element in nums equals nums length minus 1. Interesting. So the max element and the min element has to be essentially the length of our nums. So that just basically means that this has to be continuous. Like, you have to have some minimum value that starts at the left-hand side, and you add 1 up until you reach the max value at the top of the array. Okay. For example, 4, 2, 5, 3 is continuous, and that's because you could rearrange this to be 2, 3, 4, 5. But 1, 2, 3, 5, 6 is not continuous because there's no 4 in here. Okay. Return the minimum number of operations to make nums continuous. Cool. Then we have some examples. Again, 4, 2, 5, 3. So this is 2, 3, 4, 5. If you just sorted it, that's already continuous. We return 0. No operations needed. 1, 2, 3, 5, 6. Well, in this case, we need a 4 in here. So we can change our 6 to a 4, and then we'd be good. We'd have 1, 2, 3, 4, 5. So we just have one operation. All right, 1, 10, 100, 1,000. All right, so for this, if we wanted to go from 1, we would need a 2, 3, and 4. Or we could do a 10 and have this be a 9, 11, and 12. But we can't really fill in anything in between, so I think the answer is 3. And it is. Okay, cool. So let's put 25 minutes on the Pomodoro timer and we will get started. All right, so for this one, I think there are a couple things to take note of first. Let's take a look at these two conditions. So number one, all elements in nums have to be unique. Okay, so that's good to know. We have to have unique elements. And number two, the difference between the max and the min have to be equal to the length of this array. But that's more like just saying we just need to have our array be constantly increasing by 1. Okay, so I think the first thing I'd want to do is, well, let's see, what is the first thing I want to do? All right, so I think to do this one, it helps to sort of work forward. Like, we'll choose some starting point, and then we'll predict what does our array need to be. So for example, if we took every number in our nums list and said, this is the number that starts our answer, starts our continuous array. Now at that point, we've set this number as our very first number, element 0. That means we already know what all the rest of the numbers have to be. They have to be all the numbers up to the max length of our nums here. So that's pretty straightforward, actually. Let's do this. Okay, so we'll have some result. We'll set it equal to, well, we don't know, but we can start with our max, which will be the length of nums. So if we had to change every single num to have a continuous array, this will be our result. Most likely that would be not reasonable. I mean, we could change everything except one of our numbers, so we could actually do this a little bit better. Okay, we can always keep one of our numbers. All right, now at the end, we'll return our result. Okay, so I think we'll take the straightforward approach. We'll just go through every number in our nums, say, what if this is our starting number? Then we'll just create our actual, well, we can either create the actual array, or even better, we can create a set. So we'll create a set that just represents all the numbers in our constructed array. And then we can compare that set to the numbers in our actual numbers here. So we can create another set out of our actual numbers. So we have the set of numbers we would need for our constructed array. And then we have the set of numbers we actually have. Now the difference between those two sets, well, that's the number of operations we'd have to perform. So this is actually pretty straightforward. All right, so let's have a nums set here. That's just going to be a set of all of our numbers. Okay, now that we have this, we can say for every num, I'll just call it n, in nums set, we'll pretend that this is the start of our array. So if that's going to be the start, then our end, or our array itself, will just be the range from this num all the way to the end of our count. So let's actually create that here, a nums count. Nums count, that's going to be length of nums. Interesting, I'm calling length of nums twice, so maybe I'll put this at the top. All right, so our number count will be the length of our nums. Our result can start at nums count -1, because we can always just use one number and then build our entire array out of that number. All right, so I don't need this anymore. Then I do have my nums set. So this is the set of all the unique numbers we have in our nums. Then for every num in our num set, we'll just pretend that this starts our constructed array. So I'll have, what do I call this? I don't know what I'll call this. Like, I guess I'll call this like the result set. So if we were to start some array with this number n, then we would have to have a set of numbers that are in the range from n to n plus this nums count. Is it nums count or nums count -1? So if we had one element, let's just say our n is 1, and we also have one element, nums count is 1, so we'd want to go from 1 to 2. All right, so I think this works. So n, one element, 1 plus 1 gives us 2. The range is not inclusive, so this would go from 1 to 1. All right, I think this is good. So this is the expected set. Maybe I'll call it that, expected set. All right, so the expected set of numbers we would need if we started our array with this number n would be the range from n to n plus nums count. All right, now we just have to see what is the difference between our expected set and our actual set. So the delta is going to be our expected set minus our nums set. All right, how many numbers do we really need? Minus how many numbers do we actually have? If we are missing some numbers, that'll appear in our delta. So our result will then be the minimum of our current result, or this delta. All right, and I think that's it. That actually seems too easy for a hard problem, so there's something probably not right here. Let's run this, see how we do. Z set an int, right, so this will be length of our delta. So this is actually the length of the expected set minus the nums set. There we go. Okay, that surprisingly works. Let's give this a shot. And we have a time limit exceeded. We actually do fairly well. 56, 55 of the 62 test cases pass, so not too bad. We have a decent algorithm. I would say for an interview problem, this would be a good start, a really good start. Now, we have to refine on this to get this to pass. Let's see what we can do. This is going to be tricky to refine. There's not a lot of code here, so there's not a lot of places that we can save on time. Now, we do have these sets. Creating these sets over and over again, especially with these ranges, that's probably where the most expensive operations occur, creating these sets. Now, if there's something we could do to avoid creating this set every time, that might save us some time. One thing we could do is create a set and then, let's see, just add or remove elements to one single set. But I think that doesn't necessarily work, because if we have these big jumps, like we'll create a set with 1, that would be 1, 2, 3. Our next set, which will start at 10, which will be 10, 11, 12, that doesn't have any overlap with our original set. So we're going to have to recreate that entire set over again anyway. So that doesn't really save us anything. Let's see. Well, I still like the idea of sort of projecting. If we started at this number, we can project what our array would look like and find out how many of our current numbers in our number set match our expectation. I do like that. Now, if we can find a better way to do it, that's what we need to do. Let's see. I think I might need to do a little bit of research. I will be back. Haha, okay. So after a little bit of research, I have a solution This isn't my original solution. This is sort of a take on an existing solution, but it's similar to what we've done here with a slight twist. So the main things here that take up time are this creating of these sets. Now, instead of creating these sets, let's sort all of our numbers first. Once we've sorted our numbers, then we can just keep track of our current number and where we expect it to end. So we'll still do something similar to this, where we'll go through every number and try to project the length, or not the length, the numbers that are required for our particular array starting at this number. But we'll go through and essentially, how do I describe this? We will be starting, maybe I can describe it with code. Let's see how we do. All right, so I still want this result. I still want my nums count. But one thing we can do, this input might have duplicates in it already. So one thing we could do is remove some of our duplicates by creating this set and then getting the count from the set instead of from the nums here. All right, so this will save us a little bit. It'll be the length of the nums set. All right, I think the other thing we might want to do is sort our numbers. So let's do that. Let's remove this. Now, if we sort our numbers, then we can sort of make one pass and just keep adding on to our previous pass. So let's see, I'll do a sorted numbers. That's just going to be sorted nums. All right. Now, instead of going through every num in our set, we want to go in order. So we'll go for every index and number. Should I call it num? We'll call it start num. So for every index and the starting num in our sorted, let's see, I'll enumerate our sorted nums. Let's see, I'm going to get rid of these two. All right. So for every start number in our sorted numbers, let's pretend that this is the start of our new array, our constructed array. So now we need to have some end number. Let's have some end number out here. Num, and that's just going to be, actually I can create the end number inside. I'll have a current index or an end index. How about that? Shoot, I don't really like that name either. Start number, or I'll call it end index. We'll start at 0. Okay, so we've got our start number, our current start index. I'll call this start index, I guess. And we have our end index. So now we need to go through what's our projected end. So I'll call this like projected end number, or end number. I'll do that. So the end number that we're looking for, that has to be our start number plus the number of our elements. Actually, I lost that. Shoot. I'll have to create that out here. Nums count. This nums count no longer helps us. We want nums count that's actually the length of our nums. All right. So if we're constructing an array, it's going to start at this start number. It has to go from the start number to, and it tells us here, nums length minus 1. So the difference between the min and the max elements have to be nums length minus 1. So that has to be the start number plus the nums count. So let's say we have 2 elements, and we have start number is 1. So we have to have 1 and 2. So 1 plus 2, it's going to be 3, that's going to be our number. So actually we need to do minus 1 here. Start number plus the nums count minus 1. All right, that's our end number. Now, our current index, or our end index, maybe I should call it current. I don't know. So our end index is going to start at 0. And we're going to start moving it from left to right. And as we're moving it from left to right, we're going to keep track of whether or not we are still within this window. If we are still before this end number, that means we're actually building up our set of numbers. So the set of numbers in this array. And if we have enough numbers that are in this array, then how do I describe this? Man, let's do this. So while our end index. So while our end index is less than, we don't want to exceed our length of numbers here, our nums count. Oh, interesting. I just saw another issue. So these sorted numbers could still have duplicates. So what I really want to do is have this be sorted list of this set. That's ideal. Let's do that. So we'll create a number set, and then we'll have a list from this set, and then we'll sort that list. This numbers count, however, still needs to be based on the original numbers. All right, so now while our end index is less than our current nums count, we don't want to exceed, but actually this nums count isn't really what we want either. Where am I using this? I still need this nums count. I'll have a max index out here. This gets complicated when you start mixing up your different arrays. Okay, so the max index has to be the length of our sorted nums. Again, because we're removing duplicates, this could be shorter than our actual input. All right, -1. All right, so now this has to be less than our max index. All right, less than or equal to, I guess it could be. All right, so while the end index is less than or equal to our max index, and while the sorted num, let's do that, at this index is less than our expected end number. That means we are somewhere in between our start number and the end number, which means that we are actually building up this list of elements, or the list of elements within our start index to our end index. Those elements are already guaranteed to be in our range from start number to end number. Now that means that the only elements that we're missing are going to be between our end index and I guess our projected end index, which would be the end count here. Where is that? Our max index. No, not max index, nums count. Wow, this is not making any sense the way I'm describing it. Let me see if I can describe this another way. Just as we did before, we're going through every number and we're going to declare that this is our start number. Now we know our end number has to be our start number plus the number of numbers in our original input, -1. It tells us that right here. Okay, so we know what our end number has to be. Now we'll just go through our current sorted array here, and if our current end index, as long as we're still within that length of the array, so we're still in bounds, if that number is less than the number we're expecting, so if the number that we're currently at this end index is less than the number that we need to make our current start number be in a continuous array, well then we can just advance our end index. We'll just go to the next number. Now as soon as we run out, either we run out of bounds or we exceed our end number, then we can check how many elements did we actually have between our start index and our end index. Now we need to have this number, this nums count, in between. Now if we don't have that many, then the difference is how many new elements we'd have to introduce, or how many elements we would have to change. So that means our delta here, or our operation count, maybe I'll call it that, op count, that's going to equal our end index minus our start index. All right, and then we need to take, so that's how many elements we actually have in our array. Actually it's +1. So if end index and start index are the same, we still have one element. And then the number of operations we need to perform will be the number that we are expecting minus the number. So this is how many numbers we need in our array. This is how many numbers we have in our array. So the difference will be how many operations we need to perform. So now what we need to do is just update our result. So our result equals the min of our current result, or this new op count. Oh man, this is tricky. Let's see if we do any better. All right, let's see, we got something wrong. Oh, I don't have nums count here because I moved it. All right, this is actually going to be length of nums minus 1. I think I'll just do it here, make it simple. Yeah, I know we have it duplicated. It's okay. It's not the thing that's causing us to go slow. All right, and we don't quite pass. Let's see, we passed 2 out of the 4, and we are close. Wow, look at that. We're off by 1. So let's see, what am I missing? I think it's this one. I think I actually don't need this one. Let's see if that is the difference. And now I flipped. Now we're getting this one. So I think it's this guy here. And this guy. Okay, so I was just off by 1 with a couple of those. Man, this is tricky. I'm down to 2 minutes. I don't have time to go through and try to explain that. So I'm just gonna submit, see how we do. And we do pass. Oh, that was a struggle, but we do really well actually. We beat 90% for runtime and 29% for memory, so actually we do quite well. Now again, I did not come up with the solution on my own. I did a little bit of research, I came back and was able to implement it. So if you'd like to find out more, check out this problem and check out the editorial. That will be super useful. It's got some great information in here. All right, now we're totally out of time, so I hope this made sense. I know this one's a rough one, but I hope you learned something. I hope you had fun, I hope you enjoyed this, and I hope you can go out and write better code.